Good morning. Let us continue problems from previous year's question papers. This question has occurred in May 2014. Okay, so let us start. Question number 2. Let alpha and beta are the roots of the equation px square plus qx plus r is equal to 0 such that p not equal to 0. If p, q and r are in AP and 1 by alpha plus 1 by beta is equal to 4, then the value of modulus alpha minus beta. Options A. Square root of 61 by 9. B. 2 root 17 by 9. C. Square root of 34 by 9. And D. 2 root 13 by 9. Question. Let alpha and beta are the roots of the equation px square plus qx plus r is equal to 0 such that p not equal to 0. If p, q and r are in AP and 1 by alpha plus 1 by beta is equal to 4, then the value of modulus alpha minus beta. Options A. Square root of 61 by 9. B. 2 root 17 by 9. And C. Square root of 34 by 9. And D. 2 root 13 by 9. Okay. Here we are given a quadratic equation and its roots. Also we are given a relation between the roots of this quadratic equation and a particular condition that the constants in this equation are in arithmetic progression. Okay. Using these results, we have to find out the value of modulus alpha minus beta. Okay. For that, first of all, we find out the values of sum and product of the roots of the given quadratic equation using the given results. Okay, we are given a relation between the roots of this equation and a particular condition that the constants in this equation are in arithmetic progression. Applying that conditions, first of all, we find out the values of sum and product of the roots of the given quadratic equation. Okay. Then we have to find out the value of modulus of alpha minus beta. For that, we find the value of alpha minus beta the whole square and then take the square root of alpha minus beta the positive square roots. Here we are asked the modulus value of alpha minus beta. So we take the positive square roots of alpha minus beta the whole square. Okay, that is the procedure. First of all, you try to find out the sum and product of the roots of the given quadratic equation using the given conditions. Okay, just try yourself and you will see after 5 minutes. So, we are given a quadratic equation and its roots. Also, we are given a relation between those roots and a particular condition that the constants in this quadratic equation are in arithmetic progression. Using these conditions, we have to find out the modulus value of difference between the roots. Okay, that is the question. For that, first of all, we find out the sum and product of the roots of the given quadratic equation. that is alpha plus beta and alpha beta. Comparing with the standard form of a quadratic equation, ax square plus bx plus c is equal to 0. Here a is equal to b and b is equal to q and c is equal to r. Then we find out the sum of the roots, that is alpha plus beta. We know that sum of the roots of a quadratic equation is minus b divided by a, that is here minus q divided by p. Next we take the product of the roots alpha beta. We know that product of the roots of a quadratic equation is c divided by a, that is r divided by p. Next we consider the given conditions, and using these conditions we find out the exact values of sum and product of the roots. Okay, first of all we consider this result, that is the constants in this quadratic equation are in arithmetic progression. Okay, when we are given three numbers are in arithmetic progression, we can say that the 2 times the middle term is equal to the sum of the first and last term. Okay, so applying that property here, we can say that 2q is equal to p plus r. That is, when we are given three numbers are in arithmetic progression, we can say that 2 times the middle term is equal to the sum of first and last term. Here we apply that property, then we get 2q is equal to p plus r. Then we put that equation as 1. Okay. Next we consider this relation, that is relation between the roots of the quadratic equation. We just then 1 by alpha plus 1 by beta is equal to 4. Just take LCM and simplify. We get here LCM is alpha beta. On simplifying, numerator becomes alpha plus beta is equal to 4. Then become, here we have alpha plus beta is minus q divided by p divided by alpha beta is r divided by p. Then p gets cancelled. Then this becomes minus q is equal to 4r. Okay. Next we substitute this value here and find out a value for p. Then equation 1 becomes 2 into q, that is here minus q is 4r, so q is minus 4 into r, that is 2 into minus 4r is equal to p plus r. So this becomes minus 8r. Then this r can be converted into LHS. That is, this becomes minus 8r minus r. That is, p becomes minus 9r. So we get the values for p and q. Now we substitute these values here in order to find out the exact values of sum and product of the roots. So alpha plus beta becomes minus q divided by p. Here minus q is 4r and p is minus 9r. R get cancelled and this becomes minus 4 divided by 9. Now we consider the product of the roots alpha beta. Alpha beta is r divided by p. Here p is minus 9r. So this becomes r divided by minus 9r, and so that becomes r get cancelled and that becomes minus 1 by 9. Now we obtained the exact values of sum and product of the roots. Next we find out the value of modulus value of difference between the roots. Okay. So we obtained the sum and product of the roots of the given quadratic equation, and next we have to find out the modulus value of alpha minus beta. In order to find out the modulus value of alpha minus beta, we find out alpha minus beta the whole square and then take the positive square roots of that. Okay. Next, we only have these values, and using these values, how can we find out alpha minus beta the whole square? So, convert alpha minus beta the whole square into an equation containing these. So we have alpha minus beta the whole square can be written as alpha plus beta the whole square minus 4 alpha beta. Now just substitute these values and simplify. Alpha plus beta the whole square becomes 16 by 81 minus 4 into minus 1 by 9 become plus 4 by 9. Now just take LCM and simplifying, we get here LCM is 81. So this becomes 16 plus 36, that is 52 by 81. Okay, so we obtained the value of alpha minus beta the whole square. Then modulus value of alpha minus beta is the positive square roots of alpha minus beta the whole square. That is modulus value of alpha minus beta is the positive square roots of 52 by 81. So just find out the square root of 52. Square root of 52 is 2 into root 13. So this becomes 2 root 13 divided by square root of 81 is 9. So we obtained the modulus value of difference between